Okay, it's been a while since I made my last video. All of you guys are probably waiting anxiously for my newest video, so we'll go ahead and get started here with simplifying radical expressions. We'll leave that as the... Alright, so a radical expression is an expression that has a radical symbol. Who'd have thought it? Who'd have thunk it? So I have two examples here for you. 2 root 3 and the square root of the quantity x plus 3. Now, both of these radical expressions have something in common, and it's that the index on the radical is a 2. The index goes right there, a little 2. And I didn't have it written initially because the index, if it's not written, is automatically assumed to be a 2. If it is written, then it's going to be something other than a 2. So for instance, let's say I took the square root of 9, and you guys would automatically say that that answer is 3. Well, why is it 3? It's because 3 times 3 equals 9. And how many 3's do we have right here? Well, we have 2 of them. So the index, whether you knew it or not, is a 2. 2 3's multiplied together give you 9. Now, I could change that index. Instead of a square root, we could make this a cubed root. And I could say something like, what is the cubed root of 8? And that would be 2. And why is that? Well, it's because 2 times 2 times 2 equals 8. So 3 2's give you 8 when they're multiplied together, and that's why the cubed root of 8 is equal to 2. So this little number right here is called the index, and if you don't see it, you can assume that it's automatically a 2. The number or the expression underneath the radical symbol is called the radicand. So right here it's x plus 3, here it's 3, here it's 9, here it's 8. It's called the radicand. Alright, so let's go ahead and solve some problems here, simplify some expressions. Let's see, we're going to start off with the square root of 192. Here's how I'd simplify this. I'm going to make a factorization tree, and I need two numbers that multiply to give me a 192. So I'm going to start out with 2 and what would it be, I guess? 96? 2 and 96, that looks right. Now 2's prime, so I circle it. Then for 96, I could have 3 and 32. And I'll circle 3. 32's 4 and 8. 4 is 2 times 2. 8 is 4 times 2. Circle the 2. And 4 is 2 and 2. So I just wrote the number 192 as a product of prime numbers. If I count up all my 2's, 1, 2, 3, 4, 5, 6, I have 2 to the 6th. And I have 1 3 that's circled, so 2 to the 6th times 3 is 192. That's called a prime factorization. So let's erase this here. There we go. Alright, so anyways, we write that prime factorization or make the tree. And what I would like to do here, we'll use a different color to show this, is I have to realize that the index is a 2 there even though I don't see it. So I look for pairs or groups of 2. There's a group of 2 numbers. So I have 2 that I bring outside. I have another pair of 2's, so I bring out another 2. And I have a third pair, so I bring out a third 2. And now I have this 3 that's circled, and it doesn't pair up, so that goes back underneath the radical symbol as the radicand. And so my final answer when I simplify is 8 times the square root of 3. Okay? This is equivalent, or it's worth the same amount as the square root of 192, but it's simplified, meaning that what is underneath the square root symbol is no longer able to be, or there are no more pairs of factors that I can pull out from underneath there. So 8 root 3 is my simplified answer. Let's go ahead and erase that And let's do the next one here. Forget about the negative 5 for a second. Let's just break up 300. We'll say 30 and 10. And 30 is 6 and 5. Circle the 5, it's prime. 6 is 3 and 2. And 10 is 5 and 2. We'll circle both of those. Alright, let's switch to another color here. We'll switch to blue. Let's look for pairs. So I see a pair of 5s and a pair of 2s. And for every pair, 1 comes out. So I already have a negative 5. Bringing another 5 out and a 2 out because they paired up. It's a coincidence that 3's under there again from right here, that 3. Then I multiply what I have on the outside, and that's going to give me negative 50 root 3. So that's my simplified radical expression. Alright, let's see here. Let's go look at a few other problems. This time we're going to throw some variables in. Alright, so let's look at just this a to the 7th by itself for a second. And let's think about what this means. This means a times a times a 7 times. So I'm going to write out 7 times. I think I am. 3. There's 6. We'll make this work like this. Put an a right here. Now we have 7 a's being multiplied together. Okay. Now I want to look for pairs of a's because we have the radical symbol. So I have there's a pair, there's a pair, there's a pair, and there's 1 left. So the square root of a to the 7th is going to be equal to a to the 3rd, because there are 3 pairs of a's, times the square root of a. Alright, how I like to think of this is if my exponent is odd, like 7 is odd, I leave 1 behind. There's my a I left behind. I'm down to 6, and so I divide that in half to get 3 on the outside. So let's actually go ahead and simplify this radical expression. So let's take the 60 and break it up into 6 and 10. We'll worry about the variables later. That's 2 and 3. This is 2 and 5. Okay, I have a pair of 2's. So that's going to come out with the negative a. So that's going to be negative 2a times the square root of 15. Where's that 15 coming from? Well, 3 times 5 is 15. A to the 7th. I'm not done because I haven't taken care of those a's yet. So from what I just showed you a minute ago, you know that since the a has an odd exponent, I'm going to leave 1 behind. So it's going to be 15a. If I leave 1 behind, there are 6 left, and I have to divide it in half to get 3. 6 divided by 2 is 3. Plus the one that's already out here is a to the 4th. So I have negative 2a to the 4th times the square root of 15a. Let's look at letter B here. This time we have a coefficient of 1, so we don't have to worry about that. What's the square root of x squared? Well, it's even. I just divide it in half. That's x to the 1st. What's the square root of y to the 5th? Well, that's an odd exponent, so I leave 1 behind. I'm down to 4, and half of 4 is 2, so that's what's on the outside. So x y to the 2nd times the square root of y would be my simplified version of that expression. Okay, let's see here. I think we have a couple more we can take a look at. Go through here real quick. Ooh, okay, I see what we have to do. Alright, so we'll do one more here. We'll do this one, letter D. The 27, I'm going to split this into 3 and 9. 9 is 3 and 3. And so if I cross out a pair of 3's, I know that I have a 3 coming out and a 3 staying inside. Alright, I left a gap here because I know I have to put some variables out here. Half of 8 is 4. Half of 2 is 1. P is raised to an odd exponent, so I leave 1 behind. I'm down to 2, and half of 2 is 1, so that comes outside right like that. And there's my answer, simplified version. Alright, so the last thing we're going to do here is a little bit of multiplication. Multiplying is pretty straightforward. If 2 numbers are under the radical symbol, you just multiply them together. So I have 8 times 12 is 96. So that's a root 96. Now I would want to simplify that, so let's go ahead and break this up into 8 and 12. Who would have thought that I'd use those two numbers? 2 and 4, circle the 2, 2 and 2. This is 4 and 3, 2 and 2. Okay, hopefully you guys are getting the idea by now. Look for pairs. There's 2 pairs of 2's, so that gives me 4. 2 pairs of 2's is 4. 2 times 2 is 4. And 3 times 2 is 6 underneath, so 4 root 6. Another way we could have done this, I'm going to draw an arrow to show that I'm starting with this original problem. The square root of 8, I could have simplified that into 2 root 2 using a tree. And square root of 12 is 2 root 3. And then if I were to multiply those two together, I'd get 4 root 6, which you see that's the same answer. So you can multiply and simplify after the fact, or you can simplify and then multiply and get an answer that way. Now, if you simplify and then multiply, you may have to simplify even after that fact. So be careful that your answer is simplified. Alright, let's do maybe 2 more questions here. This next one, we're going to multiply the numbers on the outside first. They're like coefficients. 3 and 4 is 12. And then underneath the radical we have 20b squared. Off to the side here, I'll break this 20 up. 4 and 5. This is 2 and 2. Alright, so let's see here. We're bringing a 2 out with the 12 that's already out there. That's 24 when we multiply. B squared becomes b because we divide the exponent in half, and the 5 stays behind. So that's our answer right there. And do we have anything new here? I think that's it. Alright, we'll call it a day. So that's how you simplify radical expressions.